we're starting this chapter with multiplying and dividing rational expressions. Okay, so the first question in your mind should be, well, what's a rational expression, since we're going to multiply and divide them? And I hope the thought of rational numbers comes to mind, and so the idea of a fraction comes to mind. So a rational expression can be a lot of things. A rational expression can just be 3 over 5. Okay? It could be x over x plus 5. It can get even more complicated than that. I could have x minus 2 times x plus 3 over x squared plus 5x minus 10 or something. But those are all examples of rational expressions. So today we're going to do a lot of simplifying with them. So before we actually multiply and divide, let's work on some ideas of simplifying. So my first example for you, I've got 4y times y minus 3 times y plus 4 all over y times y squared minus y minus 6. So remember, the only way to actually simplify something, when I'm simplifying fractions, so again, kind of go over here, this isn't an example I have to write down, but when you're simplifying something like 10 over 12, the reason you can simplify the 2 out of it is because you know that 10 is 2 times 5, and that 12 is 2 times 2 times 3. So since those are all being multiplied, then I can get rid of 2 over 2 because it's really the same as 1 over 1, and reduce down to 5, 6. And I know that seems like the long way because most of us are like, oh, well, I would just divide by 2 and get to 5, 6, but I'm trying to show you how you actually simplify. And the key is things have to be being multiplied to simplify, not added and subtracted. So in this one over here, right now I should be able to notice that I've got a y on the top and a y on the bottom, and there is a multiplication symbol that aren't being shown between the 4 and the y and the y and the y minus 3. So like I could get rid of those right away. I'm not going to just yet, I could, I'm just not going to, because there's one other thing I want to do as well. I want to factor in the bottom. Okay, in the denominator here, that y squared minus y minus 6, I need to factor that, because maybe some of that we'll be able to simplify with some at the top. So here, parentheses set up, y times y will give me the y squared. I want to multiply to negative 6, add up to negative 1, so I want negative 3 and positive 2. So now I'm going to go through, I'm going to use my purple pen, and I'm going to simplify things that can simplify to 1. So y over y, that's going to simplify to just a 1. Y minus 3 over y minus 3 is going to simplify to a 1. I can write the ones where I don't have to, because anytime I multiply by 1, it's not going to change anything. But that's really what we're simplifying to. These are all 1s. So on the top, if I've got 4 times 1 times 1 times y minus 4, I really just have the 4 and the y plus 4. And same kind of thing on the bottom. 1 times 1 is still 1 times y plus 2. I just have the y plus 2. And that's it then. Okay, I can't do anything else because this is only a place I'm multiplying up here. I don't have a 4 on the bottom. Can I smudge that a little, didn't I? And I don't have a y plus 2 that matches up, or a y plus 4. So final answer, 4 times y plus 4 over y plus 2. And no, you don't have to distribute this back out. Just leave it in factored form. Okay. One other side note that doesn't get talked about a ton in this section, but is kind of useful to think about as we go forward in the future. When would this be undefined? So if I had like a part B here and I asked you under what conditions would this expression be undefined? Right, and the answer to that is, like we've always known, I can't have the denominator equal 0. I just can't have that. So I'm solely focusing on the original denominator, and I can't have any of that be 0. So I'm actually going to look for what would make it 0. So I'm going to say y times y squared minus y minus 6. Where does that equal 0? Because that's what I don't want to have happen. And so, again, I'd want to go back to the factored form of this, the y minus 3, the y plus 2, and then solve for y. So y can't be 0, y can't be 3, and y can't be negative 2. So under what conditions would make it undefined? These ones. Okay. Or in other words, y can't be 0, y can't be 3, and y can't be negative 2. In this specific problem, or would make it so our whole expression's undefined. Okay, so side note over, like I said, it'll be really helpful later. The rest of what we're doing today is simplifying, multiplying, dividing. So let's do one more that's solely simplifying, just because it looks a little different. I'm interested what you guys would do with this. And then we'll do some multiplying and dividing. So this is the same kind of question as number 1, except for number 1 had a lot of factoring done for us already. So number 2, the reason I picked this one to make sure that we know what to do is because right now there's nothing I can do with this because I've got subtraction and subtraction. I don't have that multiplying. I mean, I have multiplying inside of a single expression, but I need more than that. So I need to factor out the GCF of both the top and bottom first, okay, to make sure that I can actually figure out what they have in common. So in the top there, in the numerator, I have a to the 4th in both expressions. That's it. If I factor that out, I have b minus 2. In the bottom, think about what you have in common there. A to the 3rd. So then I have 2 minus b. Okay, so this is where it gets interesting. So the a to the 4th and a to the 3rd, I hope that we can see, okay, let's simplify that. Remember that you're subtracting the exponents. It's like I have a times a in the bottom. In the top I've got 4 of those. So like this cancels all that out just so that I'm down to just a in the numerator. But the question I have for you is, what about the rest? Like, because b minus 2 and 2 minus b are not the same thing, but they're so close. Like, I hope you notice it's like, ugh, they're just, if I could just switch them around, that'd be awesome. So the good news is that we can. I mean, why not? So in other words, out of either one or the other, why don't I factor out a negative 1 so that I can switch the signs? Okay, so that's a really cool trick. Factor out a negative 1. And it doesn't matter which one you do it to. Okay, the top or the bottom, doesn't matter. So we'll just go with the bottom. Maybe it'll make it seem a little bit better. So I'm taking out a negative 1. So think about what that's going to do. It's just going to simply switch the signs because I still want a 2 here, so I need negative 2 here so that when I multiply it back, I'd still have 2. I want a positive b here. I'm just switching the signs. I'm taking a negative that wasn't there, so I need a negative. I'm taking the negative outside of positive. And then these two things, if you reorder them, think they're exactly the same thing. I've got a positive b and a negative 2. So those are going to simplify out to 1s. So in the end, I just have a over negative 1, and I can go ahead and simplify that all the way down to just negative a. And so really cool problem to figure out, wow, I can factor out a negative 1, and that makes it so I can go so much further. Okay, so on to multiplying and dividing. So when we have like multiplying and dividing, it's the same kind of stuff. Something like 8x over 21y to the 3rd times 7y squared over 16x to the 3rd. Okay, there's a couple ways to do this. You can go ahead and like multiply straight across and make it all one big fraction because that's how you multiply fractions. Or remember, you can do some like cross simplifying first, or like anything that's in a numerator and denominator that can be simplified, or anything anywhere that can be, that's something in the numerator, because you think about this is all going to become one big thing. So if there's stuff I can simplify, I can do that first, but it's your choice. You can multiply first and then simplify. I like simplifying first, but it gets kind of messy. So in other words, like the 8 and 16, because I've got 8 in the top, 16 in the bottom, I can go ahead and say, okay, well, let's reduce that to 1/2. And same with the 7 and the 21. 7's a 1, 21's a 3. And I can even keep doing that with the variables as well, but like I said, it starts getting really crazy really fast. So I'm going to stop with just doing the numbers and go ahead and combine the numerator denominator and then deal with the variables. So I've got 1x times 1y squared, so I'm just going to have x squared, or sorry, x times y squared in the numerator. In the bottom I've got 3y to the 3rd times 2x to the 3rd, so the 3 times 2 is going to be a 6. And then I'm going to go ahead and reorder these. I've got x to the third, y to the third. That makes it a little bit easier for me to tell what to do next. And remember, number is going to be fine. These, I'm going to subtract the exponents. I'd get a negative, so it would go to the denominator. The fastest way to do that is to think about, I've got x in the top, I've got x times x times x in the bottom. So I have more in the bottom. So when I subtract the 3 and 1, 3 minus 1 is 2. I'm going to have x squared, but it's going to be in the bottom because I had more in the bottom to start out with. And same kind of thing with our y's here. Y squared, y to the third. Again, kind of what I'm saying. I'm going to write it over here to the side. If I think about doing that, that's what's going to happen. So I just have y in the bottom. So again, the fast way is subtract them. 3 minus 2 is 1. There was more in the bottom, so it's got to be in the bottom. And now I have nothing left in the numerator, so I better put a 1 there as a placeholder. Okay, I could do the exact same kind of thing with dividing. So, same kind of example here. I've got 10m k squared over 3c squared d divided by 5m to the fifth 6c squared d squared. So, what's the difference? What's the difference between multiplying and dividing fractions? Well, I hope the first thing that comes to your mind when you say, I'm dividing fractions, is I'm actually going to multiply by the reciprocal. Okay, so multiply by the reciprocal. So I'm going to rewrite this then as multiplying by the reciprocal. So the first one, remember, that's the one that stays the same. Multiply by the reciprocal. So the second one is the one we're taking the reciprocal of. So 6c squared d squared in the top, in the numerator, and 5m to the fifth in the denominator. Okay, and then we're going from here. So I'd do the same kinds of things. I would simplify the 10 and 5. 10 becomes a 2, 5 becomes a 1. Same with the 6 and 3. We've got a 2 and a 1. And then, like I said, you can keep going from there. Like I see c squared and c squared, so I just get rid of those. And then maybe I'd kind of stop there and show like what I've got left right now. So I've got 2, actually 4, 2 times 2, so 4. And usually put these in alphabetical order, so I'm going to put d squared next. I'm talking about the numerator right now. K squared and then m. And in the bottom, I have 1 times 1, so that's all, and then d and then m to the fifth. And now I need to simplify a little bit more. So I've got d squared in the top, d in the bottom. If I subtract those, I'm going to have just d to the first in the numerator, because there was more in the numerator. Okay, the k squared, there's no other k's, so that's fine. And then the m and m to the fifth, again, this is m to the first. 5 minus 1 is 4. There's more in the bottom, so m to the fourth. And I guess going back on the other ones, I assumed you knew that this was x to the first, so that's why I got 2 there. Down here, this is d to the first. That's why I got 1 there, too. So I assumed we knew all that, which I think we do. So, final answer there. Okay, so we're going to make it a little more complicated, of course, right? That was supposed to be the easy stuff. Okay, so what if directions are still simplified? Directions have been simplified the whole time. What if it looks more like this? 8x minus 20 over x squared plus 2x minus 35 times x squared minus 7x plus 10 over 4x squared minus 16. Okay. Nothing's different. There's just a ton of factoring to do. So you have to think about all the different kinds of factoring you can do here. So start with this top left one. Okay. Though I don't see x squared, so it's not going to be 2 sets of parentheses. It's going to be factoring out of GCF. Okay, what do they have in common? What's the greatest common factor? So for these, it's 4. I'd have 2x minus 5 left. Okay, in the denominator of that fraction, here I've got x squared, so I'm going to have the 2 sets of parentheses, x times x. 2 things that multiply to negative 35, add up to 2 is going to be 7 and negative 5. And same thing over here. So more factoring. X and x, I want multiplying to 10, adding up to negative 7, so negative 5 and negative 2. The denominator here is kind of interesting because we've got a GCF, so I'm going to put a little like sub-step in there, I guess I'd call it, of factoring out the 4. I have x squared minus 4, just to save space on my paper. That'd be one step, and then I'd have to factor that further, so I have 4, and then difference of squares here, x plus 2 and x minus 2. Okay, and then again, remember, it's like when I'm multiplying, I'm like putting this all together, right? Like everything's getting squished together. So it's all one big fraction now. And anything that's the same in the numerator as the denominator, I can simplify to 1. So 4 over 4, that's going to simplify to 1s. Okay. X minus 5 and x minus 5, that's going to simplify to 1s. X minus 2 over x minus 2, simplify to 1s. So anything I see anywhere in there. In the end then, I've got 2x minus 5 in the numerator. In the denominator, I've got x plus 7 times x plus 2. So, same thing, let's do a dividing one. So, 2d plus 6 over d squared plus d minus 2 divided by d plus 3 over d squared plus 3d plus 2. Again, I have to notice that it's division, and first thing I'd want to do, and this is easy if you have your book, because then you can just not write the first step, but write it over as the second step of multiplying by the reciprocal. So you can write this on your paper first. Okay, that's what I'd do. I'd make sure I have it the right direction. Then again, start factoring. Okay, tons of different kinds of factoring. So hopefully you're getting as good at factoring as I am, and you can just see it. 2 terms, so factor out the GCF. So 2 times d plus 3. Denominator is a quadratic, so d times d. I need a positive 2 and a negative 1. Over here, again, quadratic, so d plus 2, d plus 1. In the bottom, there's nothing to do there, so d plus 3. Again, combine it all together. Anything I say that's the same in the numerator and denominator, get rid of. Okay, simplify to 1. So on this one, the d plus 2's are gone, and the d plus 3's are gone. So in the numerator, I've got 2 times d plus 1, and the denominator, I've got d minus 1. Okay, final answer there again. Okay, one more problem, just because I don't want you to get like tricked by something like this. And let's see if I can squeeze it over here. So if they've got something like this, x squared over 9x squared minus 4y squared, all over x to the third over 2y minus 3x. Okay. That is what we call a complex fraction. Okay, because look at it, it is a complex fraction. It's 2 fractions within a fraction. But when you really think about it, isn't it just dividing? Like this is the big division bar, right? So it's the same kind of stuff, right? It's just dividing. So if I rewrite it as multiplying by the reciprocal then, since it's division, I go up here, then I've got x squared over 9x squared minus 4y squared times the reciprocal. So gotta switch this one around. 2y minus 3x all over x to the third. Okay, so it was one big division problem. I multiplied by the reciprocal. Okay, so I need to look at some factoring, and this one might be like, is there a lot of factoring to do? There is some factoring to do. The denominator of this first fraction is the difference of squares. Okay, 9's a perfect square, x squared is a perfect square, 4y squared. So it is 3x plus 2y and 3x minus 2y. Okay, so again, we can kind of like smush this together a little bit here and make it one big fraction. The difference though here is like, okay, well, so I know that like this is going to simplify down to just x, but these don't really match up again. So remember what we did on that other problem. Like when I want something to be opposite signs, because I'm like, well, this one wouldn't quite work if it was opposite signs because I'd have both negatives, so that wouldn't really help me here. But this one especially right here, if this was just the opposite signs, I'd have that. So remember we did on the first page where we factored out a -1 out of that. Okay, and so It's going to look kind of weird, but think about what I'm saying here. So I'm saying overall in the numerator now we have 2y minus 3x. In the denominator, we've got 3x plus 2y still. And I'm saying take a negative 1 out of that, which will effectively switch the signs to negative 3x plus 2y. And then I still have that x. So I kind of just, the only thing I really did was this right here, which changed the signs. But then what's cool about that is this and this will effectively simplify to 1, because I've got the negative 3x, the positive 2y. Okay, and then in the end of all that, what's the answer going to kind of look like here? Well, in the numerator now I just have 1. In the denominator I have 3x plus 2y times negative 1 times x. I can probably, and I did run out of space here in the end, so let's scoot a little bit of paper down here. I can probably simplify this to negative 1, just put the negative 1 in the numerator. And in the bottom I've got an x and a 3x plus 2y. The order there doesn't matter. Okay, you could have the 3x plus 2y first and then the x, but there we go, there's an answer. So again, that factoring out a negative 1 right there is really, really helpful. So that's really it. I hope that it doesn't seem like too troublesome for what we're doing here. It's just a lot of fraction work, a lot of factoring, a lot of fraction work. So if you're struggling with factoring or fractions, those two things scare you, make sure you're getting a math resource right away and getting some extra practice in, because the rest of this chapter there's going to be a lot of factoring and a lot of stuff that has to do with fractions. So anyways, I will see you on Wednesday. Do the homework. Remember the homework assignment. You should have just gotten a calendar that says it. It is section A1 right here, page 534, 20 through 22, and 23 through 41, just the odds. Okay, so have that done for Wednesday when I see you again.